Alright folks, today we're going to be checking out some problems from the FMA physics exam. Let's go ahead, check them out. Nice problems, by the way, but yeah, not too bad. Number 8, riders in a carnival ride stand with their backs against the wall of a circular room of diameter 8 meters. Alright, so this is really cool. Sounds like a fictitious force problem, aka centripetal and centrifugal force problem. So here's my, I don't know, I guess this is a carnival fair thing, and this thing is apparently rolling or something, or rotating, and people are standing with their backs to the wall. I have no idea. Anyway, this room has a diameter of 8 meters, so that means the radius is 4 meters. The room is spinning horizontally about an axis through its center at a rate of 45 revolutions per minute when the floor drops, so it no longer provides any support for its riders. How does that make sense, my friend? What is the minimum coefficient of static friction between the wall and the rider required so that the rider does not slide down the wall? Frankly, this makes no sense to me. How can you not have a ground below you to support you? But I guess friction does help. You literally can't slide, and plus the force of this spinning carnival ride is gonna press you against the wall. So you know what? Honestly, let's make a FBD, a free body diagram, because when you don't know what's going on, that's your best friend, a free body diagram. So basically, here we've got a guy stuck to the wall. And what are the forces acting on him? Well, something is obviously, number one, pulling him up. Obviously, he's got gravity pulling him down. So that's Fg. Maybe I have to zoom out a bit. There's also the normal force, which does not exist vertically, but it does exist, however, horizontally in this case. This is the normal force. Now you might be thinking, hey Rifa, there's no other force here. But if that was true, this guy would go flying into the center, right? Unfortunately, thankfully, I guess that's not true. There is a fictitious force, I guess, and that's pushing him out to the edge, right? Of equal magnitude to the normal force. By the way, I gotta move this upwards so that I have some more space. Anyway, so let's call this F centrifugal, centripetal. Centripetal is towards the center, so let's say this is centrifugal. Anyway, what's this guy's mass? Does it tell us? No, we just need to find the force, the coefficient of static friction. Okay, so that's our goal, to find mu sub s. What's the information we know? We know that this wall, this kind of wall, oh, by the way, instead of doing Fn and F centrifugal, why don't we do Fn this way and F centripetal this way? That's smart. That's smarter. Because I don't know what the formula for centrifugal is. Anyway, probably doesn't exist. We know that the diameter of this thing is 8 meters, so the radius is 4 meters. What else do we know? We know that the room is spinning horizontally about an axis through its center at a rate. So, you know, I guess it would help if I drew things in transparent color. So that would be 4 meters. 4 meters. And this thing is revolving, right? This thing is revolving. So hopefully that's a better diagram. It's revolving around some kind of a axis, and it's revolving at a speed of 45 revolutions per minute. Revolutions per minute. Okay, so what does that tell us? Can we do anything with this information? Yes, we can. Yes, we can. We want to find mu sub s, right? So why don't we first set some things equal to each other in the y direction? we have force of friction equaling the force of gravity. Force of friction, of course, being mu Fn, and force of gravity being mg. Fn in this case would be, you know, the centripetal force, so that's that. And mg, we'll keep that there. Centripetal force, by the way, hopefully you recall the formula, is mv squared over r. If you forget the formula, like I always do, here's what you should keep in mind. Centripetal force is proportional to mass and velocity, and inversely proportional to the radius. So the larger your radius, if you're Pluto, centripetal force is, you don't really care about it. If you're Earth, it's a bit of a concern. So yeah, the larger the radius, the less centripetal force. The greater the mass, the greater the centripetal force. Yes. Okay. With that being said, let's go ahead and keep going. I guess now we can go ahead and cancel out these masses. That's why the problem didn't give any masses. And we're supposed to solve for mu sub s, so maybe I should label this mu sub s, since this guy's not moving. Well, he is moving. I mean, if you're an outside observer, you'd say he's moving, but if you're in his reference frame, you'd say he's at rest. So, you know, things are complicated. So mu sub s is going to be gr over v squared. So g, of course, the competition tells us to use 10 meters per second squared. Our radius is 4 meters. Our velocity squared, what's our velocity? Oh, 45. 45 revolutions per minute. Let me zoom out a tad bit. 45 revolutions per minute squared. And now it's about time that I move all of this up so I don't run out of space again. Okay, that's better. And now let me just go ahead and, yeah, let's go ahead and calculate this. So 10 times 4 is gonna give us 40. By the way, you can discard the units at this point. Coefficient of frictions, static or kinetic, don't have units. They're unitless, as a matter of fact. 45 squared is 2025, coming up in 4 years. So that's mu sub s. And let me go ahead and approximate that. And that's going to be 0.01975. Is there anything close? No. Did we make a mistake? First of all, let me round. So this should be 0.02. So there's no answer that's actually particularly close to what I got. So what could I have done wrong? Oh yes, this is revolutions per minute. Oh my god. Oh my god. So I've got to convert this. I have to convert this into revolutions per second. So let's do that. So 45 revolutions in 1 minute. Well, 1 minute, as we all know, has 60 seconds. So that tells us there's 3/4 of a revolution happening every second, sorry. That's a lot of revolutions. Too many revolutions is bad, according to Napoleon. So, by the way, is 45 over 60 actually 3/4? Thank God it is. Now, we can go ahead and substitute. Maybe now we'll get the answer. So 40 over 9/16. And what would that be? 40 over 9/16. And that's an absurdly big number. And I'm not sure what I could have done wrong. Let's see. Oh, wait. 40 over 16 over 9. 1 second. Let me try that out. That gives us... Wow, that's even worse. Okay, so... And of course, coefficient of friction can't be greater than 1. So choice E is definitely not possible. What could I have done wrong? Did I use the correct radius? Yes. V squared over R. Did I even derive the formula correctly? Let's start over with that. Right? It's good we make mistakes, but let's check it out. So we have mu s v squared over R, and that's equal to G. So mu s times v squared over R is equal to G. So mu s must be, oh, sorry, mu s must be equal to g times r over v squared. Oh, I think I wrote the wrong formula before. Oh wait, no, this is what I got. Anyway, so gr, so what is our gravity? That's going to be 10. So 10 times our radius divided by our velocity squared. So what's our velocity? What is the maximum coefficient of static friction so that the rider does not slide down the wall? So v, let's say our velocity is 45, but we actually converted that. So 45 revolutions per minute should be less when you convert it to seconds. So 45 revolutions every minute. So every second there will be 45 over 60, which is 3/4. But that doesn't help us. This is kind of troubling. But I have a backup. I think I know what I should do if this method doesn't work. 10 times 16 over 3. So what is that? 160 over 3. Yeah, it gives me an obscenely large number. So, I mean, I'm confident about all the constants in the problem except my velocity. My velocity is the kind of thing I'm a bit worried about. So, you know what I'm going to do? I'm going to be smart and just plug in. Wait, did I get 53? Oh, wait a minute. 53.33. I got 53.33 for my coefficient of static friction, and that's pretty much choice D, 0.53. All right, folks. So number 8, choice D.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.